Normal distributions. You can pause the video and read what is written here about normal distribution. And on the right side, you also have a special normal distribution. It is called standard normal distribution because here the mean is equal to 0 and standard deviation equal to 1. So we'll solve problems using normal distribution. First example is on sales. Question is given here. The monthly sales of a retail store are normally distributed with a mean of 50,000 and standard deviation of 5,000. Find the probability that in a randomly selected month, the sales are more than 55,000. Put two values here. Mean is 55,000, 50,000. Standard deviation 5,000. We have to find out what is the probability of the sale being more than 55,000. First, we have to find out what is the Z score. That Z score is required for normalizing this data so that you get 0 as the mean and 1 as the standard deviation. Formula for doing that is take x minus mean. In this case, 55,000 minus 5. 50,000 minus 50,000 divided by the standard deviation. Exactly written here. 5,000. So this is a formula. 55,000 minus 50,000. Put everything in brackets. You get 5,000 here divided by 5,000. That becomes 1. Now there is something on the Z table which you can download or you can take a printout and keep it with you for examination purposes. Because spending time in downloading there. So from the Z table, you have to find out what is the probability for 1. So that is here 1 and 0. 1.0 is 8413. So the what it means is the probability of something which is up to 55,000 in this graph. Suppose we say that now, yeah, got this 0.8413. What it signifies is that this value of 55,000 corresponds to something close to 1 because this is 1, but we are interested in 0.8413. So if we draw a line somewhere here, from here to here. Now, what is the area of the under the curve? It is from here, from infinity, minus infinity. From here, it goes up to here and 0.8413 comes here. What is the area under this curve? That is the significance of the probability corresponding to a particular Z value. Now, Z value here is 0.8413. The area under the curve comes out to be, Z value is correct. Z value is 8413. And that is the area under the curve. Now we are interested in what is correspond to 55,000. We are not interested in what is less than this one. We are interested in what is beyond that. And for that, you remember, under the curve, the total area under the curve is equal to 1. So if you want to know how much is onto the right side of this, now that will be equal to 1 minus 0.8413. So probability of x being greater than 55,000 is 0.1587, that is 15.87%. You can do this directly also without the use of the Z table, and the formula for that is normal distribution. And you click this one. X value we want to find out is 55,000. Mean given here is 50,000. Standard deviation is 5,000. And we want to be cumulative. That means we want up to that place. Up to the value of standard deviation. And up to the value of 5,000. And that comes to be 0.8413. That is what is given here. And then, of course, you have to subtract from 1. So that is how you solve this problem. Similarly, next problem, problems are same. The time taken by customers to complete an online purchase follows the normal distribution. So whenever it says that it is normal distribution, you have to use this method. It means 10 minutes. Find the probability The time taken by customers to complete an online purchase follows a normal distribution with 10 minutes and standard deviation of 2 minutes. Mean is given, standard deviation given. X is given 8 minutes and one more is 12 minutes. So we have to find out what is below the 8-minute timeline and what is below the 12-minute timeline. The difference of the two will be between 8 to 12 minutes. So we have to find out twice. Let us do from Excel function first and then go for that. Then Excel function, this is the formula. Let us find out for x equal to 8. This is say mean 10, mean 2 and true. That gives one value 1586. And this one is for same thing for 12. This gives a value of the difference between these two is equal to between 8 and same thing again would have done here also using z values. The z value is in this case 8 minus 10 divided by 2, that is minus 1. Then it is 12 minus 10 by 2, that is 2 by 2, this is plus 1. You have to find out for minus 1 what is the score and plus 1 what is the score. For minus 1 the score is minus 1.0, score is 1587. 1587. For plus 1 is another table, that is 8413. So use that also, 8413. So difference between 8413 and 86, that comes to 0.826. And same thing, you got it here also. Difference between 8413 and 1587. So probability of this customer completes a purchase between 8 to 10, 12 minutes is equal to 68.26%. Next, employee performance scores in a company follow a normal distribution with a mean of 70 and standard deviation of 10. Now, this is the opposite of what we have done so far in the last two problems. Find the minimum score required to be the 70%, 10% performers. So what is given here is mean is 70, standard deviation 10. Top 10% is the one which is to the right. So we want to know what is the score corresponding to top 10% and more. So area to the left will be 0.9. So right is 0.1. We are trying to find out how much is to the left. So X formula is X minus mean divided by standard deviation is Z score. Now we are not interested in the Z. We are not interested in the score now because that's already given as 0.9. Now we want to find out what will be the X value. If it cross multiply this, X minus mean is nothing but Z score into standard deviation. Z score equal to X minus mean standard deviation. X minus mean in the same formula, just taking standard deviation on this side. Z score into standard deviation, that is X minus mean. X equal to mean, take the other side. Z score into standard deviation plus mean. So Z score for 0.9. Now we are given Z score is 0.9. Now where is the Z score 0.9? Z score is 0.9 and the probability is 0.9. Now corresponding Z score for 0.9. So let us search for where is 0.9. 0.9 somewhere here. This is 0.9032. Nearest is 0.8997. You can make further approximation, but this is close enough. It is 0.003 less than 0.9. And what is the corresponding values? Is 1.2 here, and in the vertical it is 8. So corresponding Z score for a probability of 0.9, because 0.9 is from here, that is equal to 1.28. So use this formula. 1.28 is this value from the Z score, which is the probability, into 10, 10 because standard deviation, plus 70, which is the mean, that comes to 82.8. If you want to directly find it, there is a formula called norm dot inverse, INV. So use the formula. 90% is the probability. Mean is 70, standard deviation is 10, and that comes to 82.8155. So this is a simpler method. If Excel supports normal.inv. Otherwise, you have to use the Z table. Last problem. A national study found that college students with jobs work an average 25 hours per week. Standard deviation is 11 hours. A college student with a job is selected at random. Find the probability that a student works for less than 5 hours per week. Assume the length of time college students work are normally distributed and are represented by the variable x. To find out the z score here, it is by the formula. X is, we want 5 hours, minus average 25, divided by standard deviation, that comes to minus 1.81818. Corresponding to that, 1.8 is here. It is close to 1.82. 818 is close to 1.2. Some difference will be there. So you can choose it as 0.30344 also, or you can take approximation between these two. So I take an approximation. It comes to 0.34. Let us use it as 0.03454. And we can do directly also using norm.dist, where x equal to 5, mean is 25, standard deviation is 11. That is true. So 0.0, this is the exact number because it's calculated by the Excel function. 0345. 0345. 0345, 0345 both are. Next digit may be 8. We do a proper approximation, you'll also get that same number. That is how you solve probability distribution problems using either the formula, first calculating the z-score and looking up the z-table. Here you have the reverse of that, where you have to find out the z-score and get the x from this formula. Either of the methods you can use. Examination, if I specifically say that you have to use both the forms, both the methods, you have to use that way.